Good morning. Today we're going to talk about acid-base strength. So this is going to be on page 9 in your packet. Okay, so in the last week's video, one of the things that we talked about is that when acid gets added into water, it's going to dissociate or break apart into its ions. And acids are always going to give us a hydrogen ion and then some other kind of non-metal anion. Okay, so some kind of negative ion over here. And a base we talked about is going to produce hydroxide ions in solution. So it's going to dissociate to produce some kind of metal cation and a hydroxide ion if the base has hydroxide in the formula. Okay. So there's something called acid-base strength. So strength and concentration that we talked about in the last unit are different. We're going to touch upon that in a little bit, but its strength and concentration are different. So strength is referring to the degree of ionization. How many ions is it actually going to produce when it gets added into the water? Okay, so a strong acid dissociates and ionizes completely. So when you look at this picture over here, you're going to see that with the weak acid, not all of the particles are going to dissociate and break apart into ions. Once you added it into water, you still have some acid molecules that are still formed and haven't broken apart, but you do have some that have separated into its ions. So weak acids do not dissociate completely, but when you look at the strong acid down here, in the strong acid picture, every acid molecule has dissociated into an ion, okay, or the vast majority. Most of them are going to dissociate. So over here in this picture, you see most of these ions over here. Most of the acid molecules have dissociated into ions. And you only have like 2 that are still an acid molecule. But what we talk about, what we say is that strong acids ionize completely. So that's what you should think about. They ionize completely. There's going to be 6 strong acids that you have to know, okay? These are nitric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, sulfuric acid, and perchloric acid. Okay, you don't have to know which one's the strongest. You just have to know that these 6 are the strong acids. You'll notice that it's all of the halogens except for HF, hydrofluoric acid. Hydrofluoric acid is weak. And then a couple of the ones with polyatomic ions in there as well. Let me clear my pictures over here. Okay, so strong acids are going to ionize completely. So when we look at a strong acid, we typically just use a single arrow to show that it's ionizing completely, that it's going to break apart into its ions when it's added into water, to show that you're always going to make a hydrogen ion and you're going to make some kind of anion. All right, with a weak acid, we typically use a double arrow. This is not going to come up into play at all as far as we're concerned, so don't worry too much about it. But this is just going to show you that when you add a weak acid into water, some of them are going to break apart into the ions that are over here, but then some of these ions are actually going to reform and make the weak acid again. That's why it's a double arrow. Okay, they don't dissociate completely in water. So the other thing I wanted to point out and say is that weak is not the same as dilute. So in our last unit, we did talk about this term dilute. And dilute means that it has a little bit of solute dissolved in water. So a dilute acid means that it has a little bit of acid in a lot of water. Okay, so 1,000 liters of water with 5 milliliters of hydrochloric acid, for example, would be a really dilute acid. Even though HCl is a strong acid, it can still be dilute, okay? So then bases, the definition for strong and weak bases is the same. Strong bases dissociate completely in water. That means it's going to form some kind of positive ion and then a hydroxide anion, because bases always produce a hydroxide anion in water. Okay. Weak bases do not dissociate completely in water. For our strong bases, we're talking about group 1 and 2 metal hydroxide. So look at your periodic table. If it's a metal that's in group 1 or 2 and it's bonded to hydroxide, it's going to be a strong base. So there's only 6 listed over here, but for purposes of our discussion, if it's in group 1 or group 2, you know, rubidium, cesium, potassium, strontium, barium, it's going to be a strong base, okay? Now you'll see down here this weak base, NH3, is going to be making the NH4 plus ion, and then hydroxide, it doesn't have hydroxide in the formula. It's still a base because it's still going to accept a hydrogen ion from the water, but it's not going to dissociate completely. Some of these ions over here, the hydroxide and the ammonium that are produced, are actually going to reform and make the ammonium or the ammonia ion again. So this picture here does a good job of showing the difference between dilute, concentrated, weak, and strong. So remember, these terms do not mean the same thing. Dilute is not the same thing as weak. Concentrated is not the same thing as strong. I can have a strong acid, such as HCl, and it can still be dilute because all of the particles are going to dissociate, but there's going to be a little bit of particles and a lot of water. Or I can have a concentrated HCl where I have a lot of HCl dissolved in a little bit of water. So for example, we talked about molarity in the last unit. We can have something like 0.005 molar HCl, or we can have like what we buy from the chemical supply store, 12 molar HCl. Well, because these are both HCl, it's a strong acid. But the 12 molar is going to be a concentrated acid, whereas the 0.005 molar is going to be a dilute acid because the molarity is so low. And the same thing for bases goes as well, okay? I can have a concentrated weak acid. So for example, that's not going to show very well in the purple. So HC2H3O2. This is acetic acid. Acetic acid is not on the list of strong acids, so that means it's a weak acid. I can have 6 molar acetic acid, or I can have 0.75 molar acetic acid. These are both weak acids because it's acetic acid, and acetic acid is not on the list, but the 6 molar is a concentrated acid because it has a high molarity, whereas the 0.75 molar acetic acid is a dilute acid because it has a low molarity. So I'm going to have you guys do the bottom of page 9 as some practice with this. So just to go over some things over here, this is your chemical formulas. So you just, if it's an ionic compound, just some kind of metal, some kind of non-metal, you're going to use regular ionic compound naming when you get to the chemical name over here. If it has a hydrogen in the front and it makes it an acid, make sure you use the acid naming rules that we discussed last week, okay? You're going to classify it as one of these things. So you have strong acid, weak acid, strong base, weak base, or a neutral salt. Neutral salt is going to be an ionic compound, okay? So if you have something that's an ionic compound like this rubidium sulfate, the first thing on the list, it's a neutral salt, okay? The strong base, weak base, you're basically looking for hydroxides on this page, okay? So if it has a hydroxide, it's going to be a base. pH, that should be one of the characteristics that you learned about when you were making your poster last week. So we know that acids have a low pH, so it's going to be less than 7. And we know that bases have a high pH, and so it's going to be greater than 7. All right. Cation and anion, so however this is going to dissociate, the cation is your positive ion, the anion is your negative ion. All right. And then litmus paper, this should have also been something that you learned about when you were making your poster. Acids turn litmus paper red, and bases turn litmus paper blue. So you'll see with the salt here, the rubidium sulfate salt, it's neutral salt, so it's going to stay red. If it's a red litmus paper, it's going to stay blue if it's a blue litmus paper. A neutral salt would not change the color of litmus paper. But you'll see with the acid, the sulfuric acid, both of them would be red. If you have a base like ammonium hydroxide, both of them will be blue. All right, let me know if you have any questions about this, and good luck.